All right, activity 5.2, we're going to determine height indirectly. So if you know the direct measurements of parts of similar right triangles, you can use proportions to determine any unknown measurements. All right, so Maureen goes to the park and uses the mirror method to gather enough information to calculate the height of one of the trees. So the figure shows her measurements. Calculate the height of the tree. I'm sorry that the image is over the words. All right, so we're going to set up proportions, a proportion here to help us solve. So you see the two similar triangles. So her height is the same or is corresponding to the height of the tree, and we're going to say h. So h over 5.5 is a corresponding side length ratio, and we can set it equal to any other corresponding side length ratios we can create. So if the height of the tree corresponds with her height, 5.5, then the base of the large triangle, which is, if you notice, all of this is 16, and this little piece from here to here is 4, so I know this is 12 feet. So the base of the large triangle, 12, corresponds to the base of the smaller triangle, 4. From there, we cross multiply, and we get 4h equals 66. Divide both sides by 4, and we get the height of the tree is 16.5 feet. All right, moving on to question 2. So Stacy wants to try the mirror method to measure the height of one of her trees. She calculates that the distance between her and the mirror is 3 feet, and the distance between the mirror and the tree is 18 feet. Stacy's eye height is 60 inches. Draw a diagram of this situation and then calculate the height of this tree. Okay, so they don't really give us a whole lot of room here. So let me draw it in black. So we've got, here's Stacy, so she's the smaller triangle, and then the larger triangle is to the tree. And then they tell you her height is 60 inches off the ground, and she's standing 3 feet. So I already know that I'm going to have to convert. So why don't we do 60 inches would be 5 feet. So her eye height is 5 feet off the ground. And then from the mirror to the base of the tree is 18 feet. And then we're trying to find the height of the tree. So a proportion we could set up would be the height of the tree corresponds with Stacy's eye height. And we can set that equal to another proportion. This is 18, doesn't look like it. 18 is the base of the large triangle, and it corresponds with the small triangle's base of 3. So cross multiply, 3h equals 50, 90. Divide both sides by 3, and we get h equals 30. And that would be in feet. Okay. Question 3. Stacy notices that another tree casts a shadow and suggests, and we're on page 85. Stacy notices that another tree casts a shadow and suggests using shadows to calculate the height of the tree. She lines herself up with the tree's shadow so that the tip of her shadow and the tip of the tree's shadow meet. She then measures the distance from herself to the tip of the shadows, and then measures the distance from herself to the tree. A diagram of this situation is shown. Calculate the height of the tree. Explain your reasoning. So again, they don't really give us a whole lot of room, but if I set up a proportion of corresponding side lengths, let's see. So again, Stacy is 5.5 feet. So she will correspond with the height of the tree. And then we can set that equal to the base of her smaller triangle is 6. And the base of the larger triangle is not 15. If you notice that the bottom from here to here is just 15, and then the rest is 6. So the entire base would be 21. And then from there, we're going to cross multiply. So we'll get 6h equals 21 times 5.5, which would be 115.5. Divide both sides by 6, and we get 19.25. Last one. Emma spikes a volleyball so that it bounces off the ground 4 feet away from her. Her hand was 5 feet off the ground when she hit the ball, and the net is 6 feet beyond the position where the ball hit the ground. The ball bounces over the net, just grazing the top of it. How high is the top of the net? All right, so we're going to label what they tell us. So they say that she is 4 feet, let's see, 4 feet away from her, the volleyball. She spikes it 4 feet away. Oh, it bounces, bounces 4 feet away. So this is 4. Okay. And then the next thing they tell us, she hits it 5 feet off the ground. And then they also tell us that the net is 6 feet beyond where it bounces. So how high is the top of the net? So we want to find X. So I'll do the proportion over here on the right, or actually I'll just change colors so you can see it over here. So we would do, we could do a number of proportions, but I would say, we can call this H actually. So H over 5, the height of the net, it corresponds with the height that she spiked it, equals the base of that, 6, over the base of the other triangle, 4. So 4H equals 30. And then divide both sides by 4. And you get H equals 7.5. And then we'll move on to section